Welcome to the next episode of Old School Science Demonstrations. Today we're doing a density demonstration. This one's called soda pop density, okay? And again, a couple things I mentioned. There is the lesson plan right next to this video and also a demo card. And even today I used the demo card. I was running a little late for the taping today, and it helped me quickly grab the materials I needed for this demonstration, okay? And we're gonna go over those right now. First of all, you need a tub or a tank like this filled with water. Now, I do have a second option here, which I'll bring up. Normally, this is what I would use. It's a plastic tub. And what's nice about it is if you drop some of the items in there that have a little more mass or heavy, they won't hit the bottom and break the bottom, okay? And you can put all the materials into this, close it up, and then bring it with you wherever you go. Now, I'll set that off to the side here. So we need our tank with water in it. We also need a couple different types of soda pop, a diet and a regular. Okay, we need a baby food jar, one filled with nails, and the second one's empty. And we also need then some sugar. And this actually, I get the amount of sugar off the can, and this particular regular pop has 39 grams of sugar in it. So beforehand, I actually pre-measured this. But if I was doing this in front of the class, I would definitely show this in front of the students. It's kind of an eye-opener how much sugar is actually in one of these cans. But I'll set that off to the side. And we'll go ahead and start the demonstration now. Now I'm going to ask the students, if I place these in water, which one's going to sink, which one's going to float? Are they both going to float, or are they both going to sink? And I would pass these around and let the kids all feel them. Now, if you feel these and lift them, I myself would probably say they're both going to sink because they actually feel kind of heavy. And in my experience with putting things in water, things that are heavy are going to sink. So let's go ahead and try it here. We'll place these in there. And what we see is that we have the regular pop sinks, and in this case, the diet pop will float. Now I'm going to give you a hint right now. When you do this, you do have to be careful though, because the bottom will catch air bubbles. So if you place it in straight like this, a lot of times the regular pop will float too, and then the demonstration isn't quite as good. But if you take and pour out, and there it actually went down though, but if that happens, you actually can take and you can pour out that air. Let the bubbles out, and then it'll definitely sink. We'll let that go down there. Now you want to ask kids, what accounts for the difference? They're both the same volume. Now if you look at density, density is equal to mass divided by volume. So it's the amount of stuff packed in a volume or an area, a space. I shouldn't say area, but a space. So if we look at this and compare these to it, we have a set volume. It's like the can's a set volume. So there must be a difference in the amount of mass in there. Something accounts for that. And a nice way to show that is to use two different items like this. I have one of the bottles here, exact same size, both the same volume. One's filled with nails and one is, in this case, filled with air. And I asked the students, which one's going to sink, which one's going to float? Are they both going to sink? Are they both going to float? With a raise of hands. And this time, I'm guessing that everyone's going to say this is going to float, this one's going to sink. So we're going to try it here. I'll be careful with this one so I don't break my bottom. What we'll see there is that it definitely does. So we have this one's going to sink, this one's going to float. So now, hopefully the kids can start visually seeing a similarity between these. I have this one full of something, in this case nails. This one must be full of something too, okay? This one here, in this case, is empty. This one must be missing something. So hopefully the kids can start to see that relationship by this example. And now we need to figure out what the difference is. So you can actually pass the cans around, have the kids look. And if you pick them up and you look, you actually can see on the back that there's a difference in the amount of sugar. This one has 39 grams of sugar, and this one has none, okay? So what we can do now is actually show the kids then how sugar can make a difference. What I have, and I got an air bubble caught there. We'll release that, let it go down. What I have off to the side here is that sugar. Now I'm going to take and add some water to this to represent the fluid that's inside of here. And I want to do is add enough water so it just barely floats. And I have pre-marked this beforehand So I have some idea where to start. And I'm just going to have to do kind of a trial and error here to get it about perfect. Give it a little push. Oh, a little too much water yet though. Actually, it's coming back up. It's about perfect. Give it a little push. We'll see it floats back up. So what I have here is I have a fluid inside the water. I have my air, and I have the glass, and I have the metal top. All four of those added together now, I know this case still floats. So the density is less than water, but just barely. I know the density of this can here is less than water, and at the same time, I also know that these two have a greater density than water. Now, if you remember back, water has a density of 1 gram per centimeter cubed, or 1 gram per milliliter. Okay, the same thing. So what we'll do now is we'll take and we'll add our sugar to this. Okay, so I bring this out, I dry it a little bit. And I'm slowly going to add my sugar at the same time, mixing it, and then I'll also give it a shake at the end. We want that sugar to dissolve the best we can. We'll probably have to give it a good shake to do that. I got a big piece there I don't want. Now, I don't need all of this, of course, because I have a smaller volume, but I need enough just to prove the point that the addition of the sugar makes it sink. Put this off to the side. I'm going to give it a couple good shakes here. Get the lid on. Set this off to the side here. Now I'm actually going to bring this more towards the middle now. So what I have is I have my original diet soda here that floats. I have my can here that has sugar in it, and I also have my nails in that jar. Now this one here now, before we noticed that it floated, but now with the addition of the sugar, we should see a drop, and if not, I'm going to have to add more sugar there. Place in the middle, and what we see now is it does drop to the bottom. So at this point, I've added enough of the sugar to make the density of that jar greater than the density of water, and it sank to the bottom. Hopefully this way, the kids can visualize in their mind what density is. Density is kind of a hard concept. It's hard to imagine mass per unit volume, okay, amount of mass per volume. But this way, when you talk about density, they can visualize in their head and actually hopefully see the jar that has nails in it and the jar that's empty and that connection between those two. Go ahead and try this. Again, make sure you check out the lesson plan next to the video and also the demo card. Again, thanks for viewing today.